Hi, welcome to week 2, June 29th to July 5th, the last installment of exponents. So part 3, exponents, part 3, guided video tutorial. This is new KNEW 6. Let's get started. We have looked at a lot of the exponent rules. So we don't really rely on the memorization of exponent rules, because when you rely on the memorization of exponent rules, what happens when you forget what you memorized, right? What we want to rely on is understanding how to use them. So we looked at basically, what do you do with them? What happens when you have 3 x's and you multiply by 3 more? Now you have 6 of them. So now you go from x to the third to x to the sixth. Or now you're dividing an x by an x. Well, that divides to 1. Again, looking at why we don't use words like cancel out, why that's problematic, okay? It's not things like the Common Core. It's because of things like that, because when you say cancel out, it goes poof into thin air. But when you say divides to 1, it makes more sense as to where it's going, right? So let's look at the rest, okay? And again, we're simplifying. We're not allowed to have negative exponents, which we haven't been able to have all along. And let's look at what happens and, where to go from here. Okay, so for this looks a little bit different, because now we have an exponent that's kind of piggybacking on another exponent. So we have x to the third, and this whole thing is being raised to the 5th power. So what this basically means is we are taking this x to the third thing, and we have that 5 times, right? So if I were to write this out, okay, we're saying that I have x to the third, x to the third, x to the third, x to the third, x to the third. Well, I know that this really means I have xxx, 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 and xxx, right? So how many do I really have? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, well, that makes sense, right? So if I have x to the third 5 times, that really means I have x to the 15th. So if I went from x to the third to the 5th, and I ended up with x to the 15th, what did I do to these 2 exponents to get there? I multiplied them, right? So following along with that logic, what would I get in number 2? With that same logic, 7 times 3 would be 21. I should get 2 to the 21st. Let's check. If I do the same thing, I should get 2 to the 7th how many times? 3, right? Which really means I have 2, 2, 2, 2, 2, 2, 2, right? That's 7. And then again, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. That's 7 here, 7 here, 7 here, and that gives me 2 to the 21. So I was right on. All right, now for number 3, okay, you might ask why number 3 is thrown in with these. Well, for number 3, this is saying I have negative 1 to the 8th power. Well, if I have negative 1 8 times, this is really just kind of testing whether you know your negative and your positive rules, because if you have a negative times a negative an even amount of times, is your answer going to be even or sorry, not even or odd? Is it going to be positive or negative? A negative times a negative will be a positive. Times a negative will be a negative. Times another negative will be a positive. So this will be a positive. This will be a negative. Times another negative will be a positive. Times another negative will be a negative. Times another negative will be a positive. Times another negative will be a negative. Times another negative will be a positive. So if you multiply a negative by an even, the answer will be a positive. If your power is an odd, your answer will be a negative. So your answer here is positive 1. So you actually know, no matter what, like you could have negative 1 to the 1113th. Your answer would be negative 1. You could have negative 1 raised to the 2,500,234th. And your answer would be positive 1. And the reason you know both of those is because you either have an even power or an odd power. All right, now, when you have multiple variables in parentheses, and you have an exponent on the outside of those parentheses, you have to distribute in to every single thing in those parentheses. So similar to the distributive property, like remember here, okay, you have to distribute here. Like I walk in and I hand half the class $5 bills. The other half of the class is going to be really upset that I didn't give half the class the $5 bill. Okay? You have to distribute that exponent to both things, to both terms. So this one is going to be a to the 8th, b to the 8th. And you're done. Both terms get the exponent. Okay. Similarly, even if one of the terms is a number, it still gets the exponent. All right. So in we go. 3 to the fourth, x to the fourth. Now, we could further simplify it. So we could further simplify that, and it will depend on what your answer choices look like. So your answer choice might look like that, 3 to the fourth, x to the fourth. But your answer choice might take it one step further. And, what is 3 to the fourth? Well, 3 to the fourth, what's 3 times 3 times 3 times 3? 3 times 3 is 9. Times 3 is 27. Times 3 is 81. So 81 x to the fourth. So either of those could be an answer. So now let's look at number 6. In we go to both of these. Two things that are important that happen here. When it gets attached to the -2, the -2 needs to get parentheses, because anytime you have a negative number that's getting put in parentheses, you are smarter than your calculator, and the number that is negative needs parentheses because stranger things could happen. So a negative number so -2 to the third. And this is the rule back from number 1, where this is multiplication, right? Because it's a piggyback, 2 times 3. Again, you could take it one step further, where this is -2 times -2 times -2. So that's -8 x to the sixth. Either one of those could be an answer, and you're done. Now it works the same way when it's division. So this goes into that and into that. It goes to both the numerator and the denominator. Which is the top and the bottom. So it's x to the fifth, y to the fifth, and we're done. Here, in we go, in we go. Here, in we go, in we go. So we have 7 to the third, w to the sixth, over 2 to the fourth, w to the fourth. We're not done. We have to keep going. We have to keep simplifying because we don't have just one letter, right? Look, we're not done there. And we really don't know what these numbers are. 7 to the third, 2 to the fourth. So we have to keep going. So 2 to the fourth, 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. 7 times 7 is 49, times 7 is, I believe, 343. So 343. I don't think 343 and 16 have any common factors. Two, 4, 8. No. All right, so our numbers are good. But now, if I have 6 W's on top, and I have 4 W's on the bottom, how many cancel out, and how many do I have left, and where are they? Well, those are gone, those are gone, those are gone, and those are gone. I have 2 W's, and where are they left? They're left on the top. So what do I have left? I have 343 W squared on the top and 16 on the bottom. And I'm done. All right, look at this doozy. All right, first off, I can get rid of the z to the 0 because anything to the 0 power is 1. Now, this 4 it looks kind of odd because of the way the parentheses are. Excuse me. But it's a parenthesis, and that everything's raised to the 4th power. So I have to give this 4 to everything, to the 3, to the x squared, and to the y to the 3rd. So this -3 is raised to the 4th power. This x squared is raised to the 4th, so it's really x to the 8th. And then I'm going to put it over y to the 3rd, which is really now y to the 12th. So the x to the 8th and the y to the 12th aren't going to simplify because they're different letters. And now I have to do this -3 to the 4th, which is going to be -3 times -3 times -3 times -3. So -3 times -3 is +9. Times -3 is -27. Times -3 is +81. So I have 81 x to the 8th over y to the 12th. And I'm done. All right. Let me know where you need help. Ask me plenty of questions, and we will talk soon.